Okay, today we're going to talk about inequalities. Do you remember back in ninth grade, when you were asked to graph something like x is less than 3?
Yeah, and then they'd intersect and shade here.
What's that?
Should have been me.
I'm videotaping, so. So how would you graph x is less than 3? On a number line. Here's 3, that's your critical value. What did you do? What did you guys do in ninth grade? You did an open circle
Yeah. And then you
and you shaded to the left, right?
Whatever way the inequality is pointing.
Right. Now, where is this graph pointing to? Where is it going to? Negative infinity. Now, if there was a bar here, what did you do different? It would be a closed circle, because it's including that critical value. Now, in this class, what you're going to do, instead of an open circle, we're going to use a parenthesis. And instead of a closed circle, you're going to use a bracket.
So the new way.
That's we did this last year, right?
Yeah.
Now, instead of writing it in set notation, here's one way you do x such that that's set notation. Instead of doing it that way, we do interval notation in this class. Do you guys remember interval notation? We did a little bit of it last year.
Yeah, a little bit.
Yeah, negative infinity. You read a graph left to right. Negative infinity, comma, 3. Now, if it's including that critical value, use a bracket. If it's not including it, it would be a parenthesis. Remember this stuff? Yeah?
Yeah.
Okay, so that's one thing that you guys have to understand. Now, what if you saw something like this?
And.
This is an and, good job. Now, the way you saw this back in ninth grade, it was like this. X is less than 5 and greater than or equal to 3, right? This is a compound inequality.
Yep.
Now, in this class, so instead of the closed circle and the open circle, you have a bracket, so that's including it, and it's going up to 5. How are you going to write this answer in interval notation? It'd be a bracket with a 3 and a 5 with a parenthesis. Now, pay attention. If this were a parenthesis, you'd have a parenthesis here, and you would not have that bar. So this should be review, right?
Yep.
Okay. Now, do you remember the basic principles for solving inequalities? What's different?
You subtract or divide or multiply by negative inequality equals.
Yes, okay. So let's practice these. This is all review, you guys, all review. And I want to make sure, write small as it, I didn't give you a lot of room, but how are you going to solve this? 5 minus 3x is greater than 7x minus 3. Plus 3. I'd like to take care of my variable first. What's the smaller variable? That one. So we're going to add 3x. And there's different ways you can do this. And I'm not teaching how to solve inequalities. I'm just reviewing this. Now what? Add 3. And then divide by 10. So you get 4/5 is greater than x. Now, how do we like to write our inequality where the variable comes first? So normally we'd say x is less than 4/5, right? That's the best way to write that. How are you going to write that? How are you going to graph that for me? What is the graph going to look like? It's going to look like a parenthesis at 4/5, and we're going to shade to the left. Now, How do you write this in interval notation?
Negative infinity.
Negative infinity, comma,
4/5.
4/5 with the,
parentheses.
very good, very good. Now, what is this class? Pre-calc. Okay, so look at the degree of difficulty. Now, this was a typical 9th grade or 10th grade inequality. Now they're gonna look like this. A little bit more complicated. So we're dealing with fractions. What did I say to do if you have fractions involved in the problem? Get rid of them. What is the common denominator between 4 and 3?
12.
So what are we going to multiply all 4 terms by? 12. Remember this? What are we doing? Why 12? What's 12 going to do?
Get rid of one.
Get rid of the.
4 goes into 12 how many times? 3. What do I do with that 3 in this numerator?
Distribute.
Okay, what about this? There's nothing to cancel, so what do I do with this 12 and 2x? 24x. I know you guys know this. How about 3 goes into 12 4 times?
So distribute.
So it'd be 4 times 2x minus 1, and then 2 times 12 is 24. Next, quickly.
Alright, distribute 3x minus 3
Uh-huh,
plus 24x.
uh-huh.
Greater than 8x minus 4 plus 24. But
Okay,
to
then
get your
what?
like terms.
Add like terms, what's 24 and 3?
27.
27x. Next.
20. Yeah.
Subtract 8x, you get 19x, add 3. I'm not teaching this. What's x? This is all stuff that you should know,
Those are both prime, which is
right?
horrible.
So, how would you graph that 23 over 19? Which is somewhere between 1 and 2. What does the graph look like? Well, all you have to do is 23/19 is our critical value. We would have a parentheses, not an open circle, and we would darken the right side. And how would you write this answer in interval notation?
23 over 19.
23/19, comma,
Infinity.
infinity. Try this next one. Miss Audia? Sure, she's on her way. Okay, thanks, bye.
Fine,
Rachel, you're on your way.
thank you. Greater than or equal to?
15 before.
Okay, next.
Yeah, you have it.
This is a review of an OR. This is a compound inequality.
Yeah.
An OR is, you look at if it hits the graph at all, it's part of the solution. An AND is where they
Meet.
intersect, overlap. So quickly, how do you do this left side? Minus 7.
Divided by 2.
Next, divide by 2. Should I flip the sign?
No, because 2 is infinity.
Good. You're not, I have people that ask me, they say, why, that's a negative. No, if this is a negative, then you flip the sign. Now, what should you do with this OR? Bring it down. Next, quickly, come on.
Okay, 3x plus 6 times
What
subtract
else?
6, then divide by 3. So 4/3.
Okay, so how do you graph this?
Okay, so plot that
Negative 14, bracket or parenthesis?
bracket.
Bracket
To the
and
left.
shade left,
Yep.
and 4/3,
Parentheses. Shade
parenthesis.
right.
And now, for $1 million, can you write this answer in interval notation?
Yeah.
What would you write?
So it's
Negative infinity,
comma
comma,
14. Negative 14 with the bracket.
uh-huh,
Clinics.
union.
Yeah. 4/3. Infinity with parentheses.
We always use parentheses with infinity. Remember that?
Did you put the union? That's what you're doing
Yeah,
now?
because there's a break there, yeah, it's this and that.
You're speeding through this.
Okie dokie, what's this one?
It's an and.
It's an and. Can you do this one all in one shot? A lot of people don't like to, but I think it's easier. If I cover this, how would you, if you didn't see this part right here, there's two inequalities here, this is an and. If I cover this, how would you solve this? What would you do?
Subtract 3.
And subtract 3, right?
Yeah. to
Okay,
-5.
if I cover this, what would you do?
Subtract 3.
So why can't I just subtract 3 here, subtract 3 here, and subtract 3 here? We can. Okay, then what?
You're gonna divide by -5, but you're gonna flip your inequalities.
Divide by -5, divide by -5, divide by -5.
Okay.
Wait, this is 16, right?
15.
15,
So
sorry.
it's gonna come out
15. Okay, this is a positive 15.
You could've just.
Yeah, you guys know what I mean. Okay, now, Nick said something about flipping the sign. Why?
Because now you're dividing by a negative number to get that coefficient back, so.
Okay, now, this is the answer. X is between, it's greater than -1/5 and less it's less than -1/5 and greater than -3. These are my critical numbers, but there's something goofy about this problem. Does anyone notice what's goofy about it? Check the order of these numbers. We always want the smaller number on the left side.
But -3 is on the far right.
Yeah, this whole thing should be reversed. So this is really what you want it to read.
So
This is-
you wanna put it back into that less than?
Yes. You want it so the smaller number's on this side. Why do you want that?
And then it just looks like.
Because it matches your graph. You wouldn't put -1/5 to the left of -3, right? So it makes sense to have this, oh my gosh. It makes sense to have the smaller number to the left of the bigger number. This is bigger. Now, X is between, X is less than -1/5 and it's greater than -3. So it's actually between -3 and -1/5. Do you guys remember doing this stuff? Yeah. All right, now this one.
I'm treating it the same.
I would, because you have a variable in the middle and a variable here,
Yeah.
I would break this one up. You might have trouble doing it in one shot. Here is one problem right here. I would break this one up. It is an and. Can you tell me what this reads? It says 2 is less than or equal to 3x plus 5. And this is the other problem right here. Can you read that to me? 3x plus 5 is less than 2x plus 11. I would do this one separately because of the two different variables. Okay, so how do you do the left side?
Subtract 5, divide by 3.
Can I write it the other way?
Yeah.
So x is greater than or equal to -1, and I'm going to subtract 2x. Subtract 5, what's x? Less than 6. So what, this is an and. Where are all the values greater than or equal to
Between,
1
yeah,
and less than 6? What is my graph going to look like?
bracket at -1, and then parentheses 6, and then shaded in between.
And now what would my interval notation look like?
-1, comma 6.
Yep.
With parentheses.
Okay, next one, example 4. What is this right here?
Factor.
X squared, what is it? It's a quadratic equation. If it said 2x squared plus 3x minus 4 equals 0, a couple days ago we reviewed how to solve quadratics. Can you tell me one way to solve the quadratics that we reviewed? There were 4 ways. Simply factor it. Well, guess what? This one is not simply factorable. Can't do that one.
Formula.
What was the other one?
Quadratic formula.
Quadratic formula we can do on anything.
Completing the square.
Completing the square. Would anybody want to complete the square on this one?
No,
Why not?
3.
The 2 here, you'd have to divide by 2 and take half of a
You
3
don't
halves
play
and
with fractions.
square it. Nah, we don't want to deal with that. That would be a mess. How about the one where you take the square root of both sides? Square root both sides. Can we perform that on this one right off the bat?
No.
Why not? Because it has an x, a middle term. Can't do that.
So you
Now,
just
there
have to-
was another way, and I'm going to show you.
Just-
Graphing calculator. So these are our 2 options,
only when
using the quadratic formula or graphing calculator. I'm going to show you both. Now, I'm not teaching you the quadratic formula right now. They did it for you here. And I don't want to waste time going through the quadratic formula. But if you use the quadratic formula, you get that answer, right?
So,
How many answers are here?
2.
2. These are called what kind of answers? Exact. These are exact answers. We could use a calculator and find the estimated answers. So if you have this calculator, the one I'm showing you up here, if I type this really quick, and if you have the Inspire, you know how to plug the formula in, go ahead. I'm going to graph it. Okay, so guess what that number is right there? And guess what that number is right there?
Answer you just got.
Negative 2.35 is that answer. And isn't it between negative 2 and negative 3?
Yep.
Now the exact answer is negative 3 minus root 41 over 4. And guess what this answer is here? This is 0.85. Now, if you don't want to use the quadratic formula and you want to find these answers, does anyone remember or know how to get these answers? We're going to spend a day on, I'm going to teach you how to do all this stuff on the calculator next week.
Second something.
You hit second, calculator, and I'm not teaching this right now, I'm just going to go quickly over it. So on this calculator, if I want that 0, it's between, I'm going to say negative 3 and negative 2, so I do negative 3, enter, negative 2, enter, enter, and there it is, negative 2.35. In that one, I'm going to do second calc, I'm going to find the 0 again, and it's between 0, enter, 2, enter, enter, and it's about 0.85 right there. Now, someone said, well, can't you just plug that in your calculator and do it? Yeah, you can. But what's quicker is to type this in your calculator and get these 2 zeros that way, not using the quadratic formula.
Remember that for your
Okay.
ECG.
Now, what is the picture of this? When we graphed it,
Gravel.
here it is right here. It's on your paper. I want you, right here, this answer, we're going to write it in decimal form. Negative 2.35,
3.5.
and this answer is 0.85. Right? Now, read this problem. I want to know where this graph is less than or equal to 0. These are equal to 0. Where do you think part of the graph is less than 0? Is common sense, is it that part or is it this part? Where do you think the less than 0 part is?
Everything under the x-axis.
Yep, you got it. I'm gonna blow this up. So are we gonna include these 2 critical values? So this is the solution. This is the region of the graph that is below the x-axis. All of these x values are less than or equal to 0, including that and that. So how are you gonna write this answer?
Negative 2.35.
Go ahead, Nick, you got it.
Okay, so it's bracket,
Bracket.
negative 2.35, comma, 0.85 bracket.
Excellent. What if this bar was not here?
It'd be parentheses.
These would both be parentheses. What if I had greater than or equal to 0? What if I had, here's my graph again, What if I said I want 2x squared greater than or equal to 0? What part of the graph am I now talking about?
The x-axis between the 2 points.
These right here, these
Oh,
branches,
just kidding.
including these critical values, these zeros. Does anyone think they know how to write that answer in interval notation? I'll start you off, negative infinity.
Point, 2.3, negative 2.35.
Uh-huh,
Yeah.
bracket,
And then you need bracket, 0.85. I'm on infinity.
Excellent. you're good. Okay, now, we're gonna do 2 more. Check out this graph right here. And we're gonna spend a whole day on these. If you were to sketch the graph of this, and I'll do it for you, just watch.
It just depends on the number.
Because, whoops, I have a visitor I have to talk to. X minus 2, 6, X minus 8. Okay, watch this. Anyone think they know what's gonna happen?
You're about to graph it.
And it's gonna be crazy.
Oh my god.
Do you guys remember last year?
Oh no.
Do you remember?
Oh jeez.
What are your zeros? Your zeros are -5,
I remember
here's
this.
-5.
Yeah,
What's this 0 right here?
2,
2, and the other 0 is
8.
8. But do you remember what it did at this 0? Because this is even, remember the multiplicity?
Oh, it's, yeah,
Bounces and touches.
yeah.
So this is what it looks like. So now I want to know, here's the graph of it. I want to know what part of this graph is less than or equal to 0. If you had to color it in, what would you say? Everything I want less than or equal to 0. So, do I color this in right here?
No.
No. Do I color this -5 in?
Yeah.
Yep. Do I color this part in?
Yes.
Yep. Do I color this in?
Yes.
This too? How about this?
Yes.
Yes? And this?
Yes.
So can someone tell me the shortest answer you can think of in interval notation?
-5. Bracket -5, comma,
Positive 8.
8,
Yep.
yeah.
Perfect. Now, see this one right here? This is factorable. If you had to factor x squared minus 7x plus 10,
X minus 5
x what?
or
minus 5
minus
minus 2.
sorry.
Minus 2. What kind of parabola is this? How, is it going like that?
Positive.
No, positive.
Why?
That's the
Where-
new value is positive.
Okay, what are the roots? What are the roots? 5 and
2.
2. So does everybody agree that that's a root? 2, 3, 4, 5, here's a root. And you don't have to be perfect, but that's basically the sketch of it, right?
Yeah.
So now, what part of this graph is less than or equal to 0?
The bottom portion.
This bottom portion, including,
-5 or 5 and 2.
would you say 5 and then 2 or 2
Or
then
2 and
5?
5.
Two and
I'm just
five.
saying
Okay.
it.
Got it?
Yeah.
Okay, I'm gonna homework one more. 53.
This wasn't bad at all.
This wasn't bad at all. This is the hardest one.
53 on the back.
53. Can anyone tell me, I want to do something with 2x plus 1.
We take, oh.
Anyone know what they want to do with that?
Factor by grouping.
Factoring. What kind of factoring?
Okay, subtract 2x plus 1 and then factor.
Subtract 2x minus 1. What do you get?
Oh, you just did it to 0 out one side.
Yeah.
Okay.
Why do we want the 0 there?
So that you
'Cause
can.
We want to find the zeros, and we want to find where it's either below that line or above. Okay?
Put a good marker right there.
So now, what am I going to do? I'm going to do this the fast way. I'm going to type in my calculator x cubed minus 2x squared minus 7x and then plus 6. I'm gonna graph it.
And
Okay, I want you to sketch that graph really quick. Just real,
I missed it.
sorry.
Looks like a -2.
Okay, so it looks something like this.
Yeah.
So now I need this number right here, I need this number right here, and I need this number right here. Those are your critical values. Can someone tell me how to find that one on this calculator?
Second.
Second, calc,
Yep.
Zero. What's to the left of that intersection?
-3.
I'm missing -3,
And then.
let's do
-2.
-1, and you don't have to guess. So what's that number? Read that right there.
2.26.
-2 point, let's just round, -2.3. Is that okay?
Yeah. Of course it's.
Okay, the next zero falls between what and what?
0, 1.
Whoops. Okay, second calc, I did that fast, 0. It's between 0, 1, and that one's about point, let's write 0.8. Let's write 0.8, 0.75, 0.8. And the last 0. Second calc,
3, 4.
0, it's between what?
3.
3.5. Okay, so now, can you tell me what part of this graph do I want? I want the part that's greater than or equal to 0.
It's up. It's those. It's that first arc.
This and that, right? So how am I gonna write this answer?
Negative. Or
Negative
bracket.
2. Yeah, bracket.
Bracket -2.3, comma,
Is it 0.8?
-0.8, bracket,
It's positive 8.
oh, it's +8, yep. 0.8, yep, and then what?
And then,
Union,
bracket 3.5, comma, infinity.
yay! You got it.
That was nice.
Okay, work on this, use the calculators, and so this page is your, this front and back is your homework. This front part is really easy. I would work in class right now on these ones. Work together, yeah, because you might need the calculator, but the other ones, you can do that at, you can do these compound ones at home, right? Yes. Hi, I'm sorry.
No, I'm sorry. I can actually wait till the end of